Hi, and welcome to my first ever YouTube video on my new channel. Okay, I'm so excited to see you here. I am hoping to teach math in a way that is not as boring as it usually is, even though it can be boring sometimes. I know it's not for everybody, okay? But I'll try and make it less boring for you. Also, I'll try and make it less difficult because we all know that sometimes learning math can be hard, but we're going to try and make it not as hard as it can be. Okay, so let's get started today. First of all, we're going to talk about number systems today. And there are more than the ones that we're going to talk about today, but let's just talk about a few for now. First of all, I made a lovely little Venn diagram of all the number systems we're going to deal with today. And a Venn diagram is exactly what you're seeing. It's literally just like circles that overlap that show you what the relationship is like between these different number systems. Okay, we're starting with the smallest one, which is natural numbers. And the reason why whole numbers includes natural numbers is because every natural number is also a whole number. But whole numbers just adds to it, and then the integers adds to that. But the line down the middle pretty much means that rational numbers and irrational numbers are completely different and they do not overlap. Okay, so let's get started with the first one. And the first one today is natural numbers. You guessed it. Okay, so what are the natural numbers? It's basically the counting numbers. If you start counting, how do you start counting? Naturally, you start 1, 2, 3, 4, 5, 6, 7, right? Exactly. Those are the natural numbers. That's where we start. It's an N for natural numbers. And the capital N is the symbol that represents the natural numbers. Okay, got it. Let's go. And on the number line, we see that there is a dot that is colored in. That means that one is included in this set, and the arrow goes on infinitely. And that just means it goes on forever and ever. It never stops. It never stops. Okay. All right. The little squiggly lines around the numbers at the top, that just means it's a set. Okay, so it's a set, and then the ellipses mean the same as the arrow. It means it goes on forever. Forever and ever. Okay. All right. Now the next number system is the whole numbers. As I said before, the whole numbers includes the whole set of the natural numbers. But we add one little number to it, and that is the number 0. And that is also why the symbol for this set has a little 0 at the bottom. So cute. Okay, let's go on. On the number line, you guessed it, we start with the solid dot. That means that 0 is included, and it just goes on infinitely in the positive direction. Next, we've got the integers. Okay, the integers, what are they? So they are all the natural numbers, all the whole numbers, but they also include the negative numbers. So now we're just including all the negative numbers. We're not even touching fractions or anything like that yet. So we had 1, 2, 3, and it kept going to infinity. 4, 5, 6, 7, 8, 9, 10. And now we have the negative equivalents of those numbers. -1, -2, -3, and it goes on infinitely in the negative direction. So you can guess what the number line for the set is going to look like. Also, the letter that represents the set is the letter Z. Why is it not I? Because there's another set that we're not learning about today, the imaginary numbers, that is actually represented by an I. So why did they choose a Z? I have no idea. Somebody probably knows, but I don't know. So here's the number line, pretty straightforward. Next, we've got the rational numbers, okay? Are they really rational? I don't know, but we're about to find out. The rational numbers is represented by the letter Q. Why not R? Because there's another set that is called the real numbers that is represented by an R. So why a Q? I don't know. I don't know. Okay. Include all numbers that can be written in the form m over n. So basically what that means is this includes all the numbers that we learned about up until now, and also all the fractions. But m and n both need to be integers. So you cannot actually write it mn, okay? It has to be, for example, 1 over 2, 3 over 4, 7 over 250. It has to be integers, and n can never be 0. I'm not going to explain that today. I'm not going to explain why that's the reason, but you're going to find out eventually, okay? Let's keep going. So here are some examples of what rational numbers actually are. So 1 over 2, 7 over 11, 2 over 1,000, 51 over 6. They can also be negative. So you can have like negative 50 over 2 or negative 7 over 3. But they cannot actually include a variable like n. So 1 over n, that is not actually a rational number, and they cannot be divided by 0. And you also cannot have a square root of a prime number. A prime number can only be divided by itself and 1. And yeah, you cannot have a square root of that. That does not make it rational. That makes it irrational. Okay, so if we write fractions, which can be written in the form of m over n, in a decimal form, they will take 3 different forms, okay? So the first one is terminating decimals. So for example, 1.24 or 1,24. You can write that as 124 over 100. So that is a form of a fraction written as m over n. So that makes it rational. Another one, repeating single digit. Repeating means it goes on infinitely, but it's the exact same number over and over and over, because 0.33333 repeating can also be written as 1 over 3 or a third, and it might show up as a little dot on top of the 3 or a little line. Then we've also got decimals with a repeating pattern. So 0,181818. If you're from America, you're going to make it 0.181818, okay? Different parts of the world sometimes do different things with math. I don't know why. But yeah, you can write that as 2 over 11 or 2/11ths, or 0.18 with a little dot on it, or with a little line on top. Okay, but you can write it as a fraction. Pretty much. Everything that you cannot write as a fraction is irrational numbers, okay? That's literally the definition of it. Cannot be written in the form m over n. Examples, like I said before, so irrational numbers include square roots that cannot be simplified. For example, the square root of 2. But they can also include special numbers like pi. And the reason why they have just infinite numbers that go on forever and ever. They do not terminate, but they don't have any repeating pattern. So there's no logic to it, basically. It's just numbers that continue forever and do not repeat. And you cannot write it as m over n. But the symbol for this is a q with a little line on top. Now, how do we say that line? We basically say q prime. That's what we call it. Okay. Hope that's been helpful so far. Here's just a quick recap of all the different number systems that we spoke about today. We had natural numbers, 1, 2, 3, 4, 5, until infinity, then the whole numbers that include 0, and then the integers that now include the negative numbers as well, and then rational numbers, which further expands the set to include the fractions as well. Then the numbers that are not included in the rational numbers at all, the irrational numbers, which cannot be written as a fraction in the form of m over n. They can be written as decimal fractions that go on forever and have no repeating patterns. And all together, they are the real numbers. So I hope that helped to simplify it a bit for you today, or maybe you just needed a recap. Either way, if you have some more questions, feel free to leave it in the comments and I will try to respond to you soon. Okay.